Just going over the basic what is Git again. It's like a way of having a version control system. So like, and if you think of Google Docs and you save something on Google Docs, you can actually go back and look at the history of it and what you saved before. So Git is doing something similar where you make a certain save to your changes, and then you could go back and review those saves. In the same way that Google Docs lets you share those versions with other people, Git can have the same sort of features, and that's where GitHub comes into play. But saving is not so simple and there's different parts to it. So you can have a new file that you created, and then it's an untracked file. But then to start to save it, you first add it to indicate that there's something you want to save, and then you commit it. And then usually along with the commit, you add a message to say that you've added it and you're sure you want to save it now. So in this example, on the first row, we have our homework one that we want to save. So we would then add homework one and then we would commit it. And so now this is our save changes. And that's the same as like saying, okay, on January 18th, we have this one version. And then sometime later, maybe in the second month of our semester, we have homework two, we finish it, we want to add it and then commit it. And then that's another thing. So I guess in terms of the Google Docs comparison, it should be flipped. But yeah, so commit to is another save. And so at any point, we say like we've messed something up, we need to go back. We can just it's called checking out. We can check out that old version and then all the files update to that. So that's the basics of what Git is. And that's kind of like the saving part. But then there's also the sharing part. And the way that the sharing part works is through SSH or Secure Shell Protocol. And it's just a way of like formatting data. It's like a pre-specified way of formatting data so it can be sent and understood by computers on either end. So, and it works completely through terminals, and that's how we'll use Git today is through a terminal. And so you have yourself here. You can use SSH to connect to a server, or you can use it to connect to other computers, as long as they're running a server software. And so the server, so we have our own computers in front of us, and the server we're going to want to connect to today is GitHub. And so that is where I'll leave the presentation, and I will go into our GitHub page that we're going to use today for our example. So the example we're going to use is the club project that we have going on right now, solids viz 1. So you can look that up and at the following URL. Let me share my screen. Okay. Yes, perfect. So you can go to github.com, sc2umich, that is our the club account, GitHub account, and then solidviz1 is the name of the repository. So we're going to be making changes to the repository today to understand how Git works with saving these changes and then sharing them. And the way that Git is really smart about it, because you can think about problems that might happen if I want to make one change and you want to make a separate change. How do those two changes come together? And it's really sort of like I guess like asynchronous way, because like you can make a change at one point. I wouldn't have to know about it until I want to make a change. Really cool stuff we'll get into today. But before we want to be able to talk to the server, but we can't talk to it yet until we have the right password because everything is secure. So first we're going to get into how to generate usernames and passwords or SSH keys in order to connect ourselves to our GitHub accounts. So one thing you can look at for on your GitHub is you can go to your profile over here if you're logged in. I guess is everybody logged in to their GitHub? And we can take time for that if we need. So one thing you can do is go to your account and go to settings, and this is where you can input your username and password that's going to be your SSH key. So down here on access, you'll see SSH and GPG. I don't know what GPG is, but I know what SSH keys are. And you can see I have a lot of them. So what you see here are all the SSH keys I have associated with my account. And what each one of these is essentially a different computer that I use this GitHub account with. So I have my home desktop, my Surface, which is this computer right here, my Great Lakes account, and all of these things or sequences of strings here are essentially my usernames for each of these computers. And that's like in a cryptographic way, I guess. And yeah, so this is what we're essentially going to be setting up. Just like a quick poll. Do any of you guys have your SSH keys set up or on your GitHub account? Awesome. Okay.
I have one in here, but it's
okay. Perfect. Yeah. Sounds good. So, okay. How does everyone have Git installed? Okay. So with Git, you should have gotten a program called SSH Keygen. And what that does is it's going to make a pair of username and passwords for you so that you can use them on GitHub. But first, we'll look at, well, first, let's do, if you're on a Windows, I think you can just do ls and it'll show you all these directories that start with a dot. But if you're on Mac or Linux, you have to do ls-a or yeah, ls-a, I think, and that's going to show you all the directories as well, which the .ssh is one of them. And if you don't have this directory, that's okay, because when you run SSH keygen, it's going to generate it for you. But if you do have one, you might already have an SSH key that you can use. So go ahead and look inside of that directory. So if you like using a terminal, you do ls and then .ssh. And so I already have a few keys here. And the one that I'm using, you can see is a, maybe you can. So I'm using one of these, this RSA or ED. It's probably the ED2551. So if I look and I display the contents of this file, it's going to be a string. So you'll have, okay, so I said before there's username and password. Username is the pub and the password is the one without pub. And you never want to show your password in essentially, because it could like I don't know, you probably don't use these SSH keys for a lot of things, but in general you don't, because it could compromise everything that you use this username and password for. So this is my public one. Oops. I'm still in the home directory, so I got to specify this directory. So it looks like this is not the one I'm using. It looks like I'm using the other one. Or maybe not. One of them I'm using. Anyways, I know which one I'm using. This one, because it's my UMich one. So anyways, what we're going to do now is we're going to do ssh.keygen, and you can just run it without any arguments, and it's going to generate you an ID RSA key. So if I run this, it's going to generate a public-private RSA key pair, and it's going to do it. It's going to say where you want to save it. If you don't do anything, it's going to save it in this typical location that you see, the default location that you see here. So I already have a key here, so I don't want to override it. So I can just say test, and it's going to put that in my home directory. So you can see I'm in my home directory right now, and I'm just running it, and it's just going to put it in my home directory. So it asked me if I want to put a password on top of my password. You can if you want to. You don't have to. And then it tells you some stuff about it generating your SSH key. So if I do ls, you can see I have two files. Here now I have test and test.pub. So these can be used on your GitHub account now. So any questions so far?
So like, what's the point? Is there a point to using an SSH key if you put the password in there?
Like the password on top of the password?
Yeah, like if you put, right, if you encode the test with a password,
Uh-huh.
then isn't it gonna?
So as far as I know, GitHub used to allow you to just put your GitHub password in to do like to authorize with it, right?
Oh,
But now it doesn't do that anymore. So it makes it to where you have to either use GitHub client, which is like something different from Git, or you can use SSH keys because it was too, I think it was too insecure for GitHub to just let you use your GitHub password anymore. And so this is the fact, I think even though you'd still input a password, this allows you to make changes from your terminal and upload them, and you just have to enter your password. Whereas otherwise, you'd have to download the GitHub client and all that. Does that answer your question?
kind of.
Yeah.
Yeah. Like, so like, I guess you can also use an SSH key for like any server, right? Like not just a GitHub one.
Exactly. Yeah.
Okay.
Yeah.
So like, if I was trying to sign on to like a different server, there's no reason, is there ever a reason to like use a passcode? I guess we just need something that's really secure.
Yeah, really secure. So, and a lot of people say, so if you're logging into SSH, like logging into a server with SSH to like automatically disable your password. So like if I do, so like, because it's another less secure option too. But then, so you disable putting in passwords. Now, I'm not talking about the password you put on top of your SSH key, but you disable just like the password you use with your login. So if I do SSH Great Lakes, and this is a different example, of course, because they have a two-factor authentication. So this is more secure than actually just using SSH key. But for example, I have a different server. If I do SSH to it, it's going to ask me for a passkey for my SSH. This is fine and pretty secure because it wouldn't ask me for my password. Otherwise, if I didn't have the SSH key set up, it would just wouldn't let me in. Yeah. Okay. Cool. Yeah. So now let's go ahead and add our SSH key. So what you're going to want to do is you can just print out your your SSH key like this, and then copy it all, the public one, and then click new SSH key, give it a title for your computer, whatever you think is more fitting, and then paste in this. That doesn't look right. Paste in what you copied.
Which part?
Like that, yeah. So then you just do like test or something like that. Okay. Bubble one, yes. Yeah. So if you do the other one, it won't work. Okay, now I am going to back out of this because I don't want to actually add a new one. Okay, so now we're going to try to clone a repository. So I'll demonstrate that, but I have the repository in another space. So I have it already. I think this is actually what I used to create the repository, but so when we clone it, you'll see you'll get all of this stuff. But just to show you how to do it, so I'm just gonna change directories to my home directory, and I'm gonna re-download it to my home directory, but then delete it later. So to clone this repository, go back to that the original solidviz1 project, and then where it says code, you can click that, and there will be multiple options. So there's HTTPS, And this is where it would originally ask you for your password, but they have gotten rid of that. Now I think this is only if you want to clone the repository but not do any uploads. So in order to be able to upload and interact with the repository, you either have to do SSH or the GitHub command line interface. So go ahead and just copy this. This is going to be the address that we're going to clone, and do git clone and then paste that in. Okay.
So just to verify, if we didn't have the SSH done, that would have worked.
I think it would have worked. Yeah, it would have worked, but you wouldn't be able to re-upload to GitHub. Like you wouldn't be able to, yeah, push your changes. Yeah. Okay, so first thing we can do once we have downloaded it, oops. So you're gonna want to change your directory into there. So we'll be working in here, and then you can just list everything that's in here. So there's a few things. There's one Python file, .github. That controls things on GitHub. Yeah, other stuff. So we're in the main branch. The way that you can tell this without having fancy graphics is do git branch, and it'll tell you all the branches you have, and then I have an asterisk next to the one that you're activated. So there's more branches as a part of GitHub than just the main branch. So there's two other ones. There's GitHub Manage and Image Test. You have also downloaded these, but they're sort of hidden right now because it doesn't just like flood your new clone repository with everything that is already on there. So if you do git branch-a, it's going to show you all these remote branches that you've done too. And so say you want to work on the image test branch. And so as you guys answered in the trivia question, like every branch kind of correlates to a different line of work that's happening on the project. So the main branch is kind of where everything is saved, and then the image test branch is going to be where we're going to be writing image tests to then save to the main branch library. And we'll get into that, how all that's going to work. So, but say you want to also work on the image test branch, you could just do git checkout and then image test. And it automatically knows that you're talking about, oh, this remote branch will set you up with that one. And so there's some extra stuff in this one now. So there's a whole test folders now in this one, and then there's a test PNG. Any questions on any of that? Okay. Yeah, so you don't have to do it to clone it because it's public. So anyone can clone. Yeah.
So if you did have a public repository that had to SSH.
Yeah. Okay, so now what everyone's going to do is to make sure that our SSH key works, everyone's going to make a new branch, and we're going to try to upload it. Since there's only five of us, I guess, it's not going to cause too much commotion. So to make a new branch, you do git checkout. So we use git checkout to convert to this branch. You can also use it to make new branches, and you just use the argument -b, and then make a name for your branch. So it'd probably just be best if you just used your name and then maybe branch. Whatever you're interested in. So this branch has been created and it's on our computer only, but we want it to be on the server now. And to do that, we're gonna have to do a few things. So since we downloaded image test from the repository, it knows the address to send it to on the GitHub repository. But since we've created this new branch, it doesn't know where to send it to on the GitHub repository. So to set up that sort of address in that relationship, we have to do git push, and then we'll have to use a special argument. So you have to say set upstream. So this is going to set the upstream address, and then the remote name, so the remote repository name, which is GitHub, but by default, Git always says this as origin instead of like GitHub or something like that. So origin is the place where you cloned it from. So that's why it's called origin. And then you put in the name of what you want it to be called on the GitHub. So you can just do the same thing as what you call it.
So if we don't do the set upstream origin, it's automatic.
It would say if you did git push origin, it wouldn't know. I'm pretty sure it wouldn't know what branch to send it to. Like it would know to send it to GitHub, but it doesn't know where GitHub to send it. So yeah, I can go ahead and test that, and we'll see what the result. So if you just do git push, it's gonna say, okay, we don't know where to, has no upstream branch. If we do git push origin, let's see what happens. Same thing. So it wants to know, and so it's even giving you this nice command here to tell you what to do when you make this sort of mistake. So we've made our own branch. There's no changes made to it yet. It's the same as the image test branch. But now we're going to push it onto the repository. So it's going to ask me my password again. Oh, okay. So here's a weird thing that's going to happen if you have multiple GitHub accounts. It thinks that I'm trying to use my personal GitHub account to do these changes, but I want to use my University of Michigan account. So what I have to do is you guys probably want to do this, but I have to set my email for this repository as the email associated with the GitHub account. No, that's not gonna work. Okay. I have to change the remote address. So it's gonna be, yeah, I always have to look at how to do this. So I'm just gonna go back to my old repository. Oops, wrong one. So were you guys able to upload your new branches?
You got permission.
Okay,
I also,
you just uploaded. So two things could be happening. You could be having a similar issue to me, where it's using the wrong SSH key. Another thing that could be happening is you have to have like this SSH key agent running, and that is what basically gives the password for you whenever you try to log in. So just really quickly, I'm gonna look at you guys set up and see how your SSH keys are set up, if you don't mind.
yeah, so I've had this set up.
Setting.
I'm doing this like from a server.
Uh-huh.
This SSH key.
So that's your SSH key on a server.
So it should be, yeah, so on this server, should be able to access my, like this GitHub account. Yeah, this is like it's labeled a personal account, but it should be associated with the image.
Okay.
And I also tried to do the git config thing,
Yeah.
and it doesn't seem like that.
So can you just show me the directory of all your SSH keys? So just do like ls. So what happens if you add that SSH? Yeah. No.
This guy? Yeah. You mean like if I like cut it?
Yeah, cat it and then add that one to SSH.
I thought it was this one.
It could be. I think it does like some sort of shortening. Okay, keys are
Yep.
and you only have one SSH, so
Yeah. And it seems to identify like this is my username on GitHub up here. So it seems to recognize that that's like, is there anything, there's not anything wrong with the permissions on the GitHub, like the solids viz one, right?
that might be it.
I don't know that I've ever like joined it. There's contributors.
Yeah, I thought everything. So Ellie, how about you? Okay, I got you. Yeah, so I will admit this is like sometimes the trickiest part um about getting this whole like remote process set up. So Sam, you were able to do it.
Yes,
Yeah.
feeding, okay, so like whenever you push your request to a repository, you don't owe parties a pull request actually.
In the main branch. Yeah.
Okay, so where it says, okay,
So yeah, I see your branch right here. Sam branch. Yeah.
get rid of that.
Yeah, we'll get rid of them all. Collaborators. Yeah, this might be what we're missing. So let me go ahead. What is your username?
I'm JSAYUT.
UT1. All right. And then Tim.
YNGSLV.
V like
ELV.
all right. Okay, so then that was probably our problem. Ellie, you want me to add you to it? It'd be like Ellie. How do you spell Eleanor? A. How am I doing?
Skipping in.
Um,
ANOR.
and
Switch the A and then. Yeah, there you
is
go. There you go.
it just Eleanor?
Is there an E at the end?
It's not.
No E at the end. That,
Should have.
Which one?
that,
Okay.
So we can't see your screen.
Yeah. All right.
my branch.
Sweet. Okay. All right. Yeah, in that case.
Oh, okay. Except later.
Yeah.
Yeah, you go and get enough.
Okay. So at this point, we've all uploaded our own work to GitHub. But that's not really collaborating with each other. At this point, we have a bunch of work that's all in separate places and it's not really into the same project yet. So we want to be able to all work on the same thing so we can collaborate. And to do this, I'm going to create a new branch called test, and we're all going to work on test to see how this is going to work. So I've created a new branch just like we did last time. I'm going to do git push, and I'm going to send it to the server. So you guys don't have to do this part. Yeah, so I'm just setting this up for us. And I'm going to make a change to this. So actually right now you guys can do git fetch, and it'll pull in all the changes that have happened on the thing. So I just got 2 new branches.
Actually, I've never understood fetch.
Okay, so yeah, so fetch is the same thing as pull, except it doesn't overwrite your current branch. So it just gets all the updates.
So it's what the file's being tracked, but it doesn't change the files.
So like, you know how there's like, okay, so there's git branch. So there are your local branches here and your remote branches.
Okay.
So fetch will update the remote branches that are on your computer still, but they're not represented in your current branches. And so so what pool does is it does a fetch and then a merge. So say like if I wanted to merge these changes from that I just pulled, so I would do git merge test and then origin. Or no, so I'm on test, so I don't need to write that. Origin test. So if I write this, I'm saying I want to merge in those changes I just fetched. So it's already up to date because no changes have been made. Okay, so Tim, how are you? Yep. All right, so now you guys can all do the same thing with git fetch. And at this point now you can do git checkout and then just test, I believe, and it should make a branch for you on your local machine called test. So next thing I want you to do is open up this project and whatever text editor you want, or just open up a text file, however you want. And if you're opening up a text file, just name the file test.txt. So we're all going to make this file separately, and we're going to show how we can merge it together. So I've opened up mine in Visual Studio Code, which is my text editor of choice. So all you need to do in test.txt is write your name. So I'm going to write my name, Jacob. I'm going to save it.
What? Okay, just
yeah, general document, make a new file, test.txt. Mm-hmm. Okay, so now we've made our change. We want to save it. And this goes back to the original process of git add. And you can use period to just add all the changes you've done. We've only done one change, so it's fine. And then we do git commit, and we add a message, be like added. So we've saved our change. Our change has only been saved on our local machine though. The next thing we're going to want to do is to push it. So certain branches are protected. So the main branch, you couldn't just push to the main branch. And we'll get into how to update the main branch later. But these branches that we're just making, there's no rules for protection on them. So we can just simply push it to the server. So I need one person to push only.
okay.
So you just do since you got downloaded that one from GitHub, you don't need to tell it where to send it to. It already knows. So you just do git push, and it should know exactly where to send it.
So the current branch has no upstream.
Okay, in that case, do git push dash dash set upstream, and then
Oh, yeah. With /test or just set?
it would be dash dash set dash upstream, and then origin, and then the name of the branch you want it to be, so tests.
So user.name, is that your username or is that just?
I name, yeah, yeah.
Origin /test.
Oh, here. So just origin and then space. So it's like 2 arguments.
Oh, yeah.
Yeah, okay.
So I just typed it wrong.
Cool. Yeah. Okay. So now I'll show you guys what happens now. So you made a change. Your name was in the file in the first line. My name is also in the file in the first line. So I want to make my change too, but obviously there's going to be a conflict here because our names cannot both be on the first line of the file. So git push. Oh, okay. An error happened. So updates are rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same ref. You may want to first integrate the remote changes, git pull before pushing again. So this is why GitHub is like both smart and dumb at the same time. It can automatically merge things, but in the case where there's the same text on the same line, you have to do it manually. So what we have to do now is have to do git, oops, pull to pull in the current changes that have happened. And it's going to say, we tried to merge this on our own, but there's a conflict here that we can't really resolve. We're going to have to defer to your judgment to understand how to fix this. And that's what you can see here. And Visual Studio Code does this nice thing where you can accept the current change, which is mine. I can accept the incoming change, which is John's. I can accept both changes, what's happening, or we can do something in the middle and compare them. So I could click accept both changes and it would do it automatically for me. But what all this button would do is it would delete this text down here. This is what GitHub generated. It would delete this middle text, and then it would delete this top text.
And wait, sorry, and that's what, how do you interpret the colors? What you're saying about?
Yeah, so the top, I think I can undo it and it'll go back to, yeah,
Yes.
So head is what yours is on your computer. And everything between head and this dash line here is what you've done. And then the conflicting stuff is what you see here. This is a hash ID representing a save change. And this is everything that is coming in, incoming. So first is what you have, second is what's incoming. And I can show you guys what the button does now. So if I just accept both changes, it does it. And then, but how you do this manually is just by deleting the lines and going through the files yourself and seeing what you want to save. And so if you look at, so say this is one file that we're doing, but say a lot of files had these merge conflicts. So you can see which ones had conflicts, but when you do the pool. So auto merging test.txt, and then there was a merge conflict. So you know there's an error in that one. You're gonna have to fix it. But also if you do git status, it'll also tell you unmerged paths. So we haven't merged this file yet. We've done the changes in the file that we need to in order to prevent the merge conflict. If this were a program would run fine now. And now we need to save those merge conflicts. So the way that we do this is we just have to add the file again, the file that was in conflict. So we can just do add everything and then commit. But you actually don't have to write a message this time because it already knows that you're trying to fix this merge error. So if you just do merge or git commit, it's going to open up a text file and it has automatically generated what you were fixing. So it's merge branch test of GitHub image, yada yada. So all you have to do is close this file. If you want to add some more stuff, be like, I removed John's name because I didn't want it there, and you do that. So, anyways, so we have our commit done now, and so if you guys have done the same thing, if I push now, and you guys try to push as well, you'll get another error because I've now made a change.
kind of merged it the same way you did, then you pushed it.
Yeah, exactly. So it's good, like it's not gonna let bad things happen, but it could be pretty tedious at times. So usually when you're working on something, the chances that you're working on it at the same time as someone else is gonna be rare. Um, I guess in most cases that I've worked on projects collaboratively, that's rare. But so you would probably avoid these problems most of the time. But it's nice to know how they get resolved. How's it going, Tim? Okay. Yeah, any questions?
Like, well, I'm using, Git Bash,
Mm-hmm.
but it says that my branch is merging. So, like,
So yeah, so you get in the same. So it's saying updates were rejected because the remote updates were not have.
so then I should try to pull it again?
Exactly. So Sam just made another change. So you got okay, so you already have an unresolved problem. So go ahead. Can you open up a text editor? So go ahead and just do git restore and then period. I guess just do scroll up. One. So you brought it in, git full, and it was saying you have this error. And then, okay, so just go ahead and like close the git, the test file, like. So one thing you can do is just do git add, and then like, and then git commit. You can just do without anything. Sure. And then it's going to say, oh, we're merging, we're fixing this conflict. And you can just, if you just close this file, it'll finish. And then another thing you do is git pull again to get what Sam just. And so now you're gonna have another. So what you have is nothing.
Yeah.
And what Sam just did is all those things. So you can just delete all the arrows and stuff and then add your name.
They're like, that's pretty sad.
Oh, sorry. Yeah, you have to add. Yeah, I do say it. Yeah. Oh, first add the text. There you go. Yeah, same thing. Now, cool. All right. So now everybody has made a contribution. You guys are all contributing members to the project, and you'll show up on GitHub now. So if we like, I don't know, we could, you guys can look at it eventually, but if you look, you can see.
Editing my resume.
Yeah, yeah. You can see, oh, so many people have contributed. I guess maybe, oh, this is for the main page. So once we we'll merge the main branch. We'll show how that works. That's actually what we're gonna do now. And then you guys will be contributors. Okay. Yeah, so another thing we can do is go to our latest uh, test push, which Sam just updated. I mean, Tim just updated, sorry. Look at our test.txt. Oh, interesting. So this one was this one you, Sam?
Yeah.
Okay.
I see it.
Okay, okay. No worries. But you can see, like, even if you leave this section, it's not gonna care about it. Like, it does this for you. Now, this will mess up your program if you're writing a program, but it's just text at the end of the day. And this is to help you sort of clarify. So yeah, so this is.
Visual Studio hides that.
Oh, really?
Yeah.
Yeah. And so we can actually look at all the previous commits that were happened on here too. So this is just the latest one. Let's see. So we can look at our history. So we can see all the stuff that has just happened now. Yeah, so there's a lot of stuff. A lot of stuff that just happened. So this is a lot of Tim did. And it's all of our names. So now we want to incorporate our changes into the main branch. And so the way you might think you would do this is to just edit the main branch and then do the same process. But there's not really any safe, as you can see, Sam made a change and there wasn't any really safeguards to prevent the sort of malformatting thing to being into the main branch. So if we had an automatic process to where as soon as something was in the main branch, got pushed to our website, and our website was supposed to run, it would be CrowdStrike all over again. And yeah, so there's reasons those safeguards do that. So most safeguards are you can't push directly to the main branch. In order to get code onto the main branch, you have to do a pull request. So what a pull request does is it gets one branch on your GitHub and merges it with your main branch, or it can be any branch, but usually it's the main branch. So we do compare and pull request. So we're going to create our pull request and you can put whatever title. So we'll just do learning and you can see what branch is going to be merged into what branch. So it'll be main branch or test branch merged into the main branch. If you were implementing a new feature and you really cared about who was going to review it and what they had to say, you would write some more description here about what you did. And then also part of the safeguards is it has to be reviewed by at least one person. And so in all of the stuff we do for the club, like our documents repository, I always get Sam to review everything. So he probably gets a bunch of emails about review this pull request so that our documents page gets uploaded. And then, so this is a bunch of like management stuff as far as like, oh, who's going to be working? Oh, I'll be working. I can also assign you guys to work on it. So if we're like doing some sort of project management, okay, I need you to work on this. This sort of, so every branch is like a task, right? So when you're assigned to a pull request, you're going to be working on that task. And then, yeah, we could add a description if we want. So we created the pull request and now it has to be reviewed by Sam. But say Sam is busy this week and he won't be able to get to it next week. And we're like, oh, aha, I needed to add this feature really quickly, but I've already made the pull request. Do I need to make another pull request? You don't actually. So if I did another, so I'll go ahead and pull in all the changes that have happened. And so I get hi Jacob.tim. Nice. So we get all these changes. And you guys might have already actually seen this if you guys have pushed anything recently. You'll see that this sort of string of commits can be updated while the pull request is still open. After the pull request gets approved and submitted, then no more commits can be added. So since this is merging main and test, any new changes that happen to test before this pull request is finished will be put into the main branch. So So say like, Sam, go ahead and if you can, like approve this, but don't merge the request, just approve it. Yeah, learning.
You don't want to,
Just approve it,
oh, you want me to,
but don't merge it. Okay. So I just made a quick change to this text file and I said breaking codes. So this is trying to illustrate a change that I made. And I'll just do message, like new features. So he's approved it. I guess I probably should have shown. Okay, so I haven't merged yet. So he's approved it, looking good. I could merge right now. Everything would go in his main merge. But I'm like, wait, hold on. I need to change this one feature. I already made the change. I committed several features. Now I'm going to push it. So since no one else has pushed in this meantime, I can still push. No other changes. And so I actually can still. This is contrary to what I thought was going to happen. Usually it like makes you reapprove it, but I guess that's interesting. Hmm.
let's see. That would-
Seems really problematic.
So I think we might need to change our permissions and
There's
stuff.
not a check mark next to that. Plus.
Yeah, like this. So yeah, these are like the
Can I merge it and let's see if it,
yeah.
oh, and okay, it says new things, since last viewed, it is, does say. It is the-
Okay, so it's telling you at least that things have changed. Okay, so Sam just merged it, and we know that these changes were made.
Features.
Okay, yeah. So yeah, maybe something to be wary of in that case then.
Oh, wait, maybe I'm not in the right. Nope, that's-
Okay. Something to be aware of. Yeah, that might be something you can change in like the settings about. I think it is a checkbox you can click.
It's like it's gonna push something in that wasn't supposed to.
Just slip it in right away, like right. So maybe don't approve it until you're ready to merge it. Maybe that's a good way to prevent that. Okay. So I'm going to make one more change, and then I'm going to tell you guys about issues, and then we'll wrap it up after issues. So issues are a way of like, so branches are a way of like separating code. Issues are a way of like keeping track of the progress on those separate features. So I'm just going to make another quick change real quick. So we'll say issue, new issue. So this is just going to represent us making some progress. And I'm going to make another pull request. So git add git commit, and then we'll just do the same thing. Git push. And then we have a new push, a new commit on the test branch, and you will probably see something come up sometimes. Up, it'll say like, oh, there's a new change. Do you want to incorporate it. So it's a little, okay, maybe not. So we'll go to pull request and we'll just make one. Let me make sure that went through. Okay, so new features. So we're going to create another pull request. So say issues is the way to sort of like delegate tasks as well and in your project. So what I've done for Solid Viz is I've created several of these tasks. Some of them are ready to start. And so like if you look at it, it's saying like, okay, here's the background of what you need to do. Here are the tasks you need to do to complete this issue. And then you can make your own branch for this issue, or you could do it on a separate branch. But then you're done with this issue whenever you complete yada yada. So we're gonna make a pretend issue and show how like the workflow of this would happen. So this is just gonna be test issue, and then it's gonna be like make a new feature. And then you can do a bunch of stuff with like project management, assign somebody to it. I'll just assign myself to it. You can assign different labels to it depending on if, oh, I need help on this one, or this one is like the one I have on it is ready to start. So I'm not still working on the issue. You can go ahead and start it. So I'll create this issue, and then the issue gets a number. So it's issue number 11. The commit that I've already done, let's just say, for example, the commit I've already done, let's say, for example, completes this issue. It does all the things. We added a new feature. That's all we had to do. So one way you can like automatically close the issue with this pull request, like you can associate this pull request with the issue. So it's like this pull request completes issue number 11, and it knows that's if you do like hashtag 11, it knows that that's the test issue. And I think complete is like also a keyword in this. It's completes or something. If you like Google like automatically close pull request, or no, automatically close issue with pull request, you'll find the features for it. So there's like keywords. So this issue, this pull request closes, close, fixes. So we'll do closes. And then I'll get Sam to approve this one, and we'll go ahead and show how that works. So Sam, if you don't mind. And so you'll see back in our issues, we have our test issue. It's ready to start. Oh, so no, you just have to you just have to approve the pull request. Yeah, yeah. Any questions while we're waiting? Yeah. Do more. Okay. So we're good. We'll merge the pull request. And that will be permanently added to this project for forever. Even if you change it afterwards, like the old commit is still there, which is really interesting. So if you look at like projects that have been open source on GitHub for forever, you can go back to their first commit on how it started. That's the whole thing. Okay, so we said it closes it, we've merged it. So now if we go look at our issues, fingers crossed, it's gone. So that's one way, that's one cool thing about GitHub too. So you could close multiple issues with one pull request, and then just remember pull requests are the way to get stuff into the main branch. And then like the main branch is what everyone sees. And that's what's like the final product is in. So if we look at our contributions, we got so many people up here now. It's crazy. Sam is just outweighing all of us over here with all of his
I
commits.
was trying to, I wanted to open with Nano on my,
Oh, the text editor, yeah.
I was trying to fix that.
Okay, so that's the end of this workshop. I hope you guys got something from it. Yeah, just if you guys have any other questions, please feel free to ask now. And then if not, we'll go through some announcements and we'll be done. Yeah, I'll just leave it like this. Oh no. I think I was sharing the wrong screen the whole time. Oh well. Sorry, Ellie.